Right. So, good evening, everybody. I hope you are able to hear me. Gayana, you are able to hear me?
Yes, sir.
What happened today? Went for online class?
Yes, sir. I have exams, sir.
Exam? Which exam you have tomorrow?
Sir, maths.
Exam means class test.
No, sir, for 40 marks.
Okay. So, I hope you are able to hear me, Surya. Your video is still off.
Yes, sir.
Yeah. Kashika, Darshan, Indumati, Shripriya, Tanushya, Harshita, Sailesh, Sarvana. Everybody is able to hear me if I am right.
Yes, sir. Yes, sir.
Today, why many students are not there? Exam anything tomorrow? Match of India, what's the match there? Zimbabwe. Okay, whatever it may be. But let us not stop our class. We have to move only. We cannot wait for anybody to come and join the class. Or now, before this class, you had practice class today, no, right? Today we have only 8 p.m. to 9 p.m. class. Okay, fine. So let us not waste any time and start the class. SSM students, settle fast, please. Yes, I can see Shoaib, you have come.
Sir.
Yeah, Mr. Akhilesh.
Yes, sir.
Karthikeyan, you are able to hear me?
Yes, sir.
And is it Prashita or is it Rini? I'm not able to see the face clearly.
Ready, sir.
Rini.
Ready, sir.
Okay, Rini is there. Prashita is entering now.
Yes, sir.
Okay. So, anybody who is there in the class sitting for their first class today, I don't think anybody is there like that, isn't it? Come fast, man. Time. Yeah. So, in the previous class, let us see whatever we have learned till now. Before we start today's topic, let us recall all the concepts of the previous class. Okay. So, up to now, in this chapter, we have learned what are the basic properties of charge, which are three: additive nature, conservation, quantization. Isn't it? And how is the question going to come from each topic also have told you. From quantization, how the questions can be asked, additive nature, how the questions can be asked, even conservation, how the questions can be asked, I told in the class to you. Then I talked to you about Coulomb's law. Coulomb's law talks about the force of attraction or repulsion between the two charges, and the formula for Coulomb's law is F is equal to K Q1 Q2 by R square. Looks very simple, but it has a twist when the question is having vectors involved in that. I said you K is called a constant which depends upon the medium. That is, K is equal to 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught. Epsilon naught is called as permittivity of free space. When I say free space, its value is 8.85 times 10 to the power minus 12. And if the medium is changing, epsilon is changing. And epsilon of any medium can be found by multiplying epsilon naught with epsilon r. The epsilon r is called as relative permittivity. It also has another name, dielectric constant K, kappa. So, if you multiply dielectric constant with permittivity of free space, then you get permittivity of that particular medium. I told you, whenever you have multiple charges, then you are supposed to solve vectors and find the net force. Whenever a question is given, when you have 4 charges kept on a square, corners of a square, or 3 charges kept in the vertices of a triangle, or charges kept around the rectangle, any kind of question, please make sure that step 1, draw the directions of forces. If you don't do that, you will do mistake. First, identify where they are asking you to find the net force, which particular charge, and then draw all the vector notations, then check how to resolve those vectors. For resolving vector, we have a formula, root over f1 square plus f2 square plus 2f1 f2 cos theta. Theta is the angle made between two forces, and then theta can be 60 degree, it can be 90 degree, it can be 120 degree. By now, I hope everybody knows allied angles, and you know what is cos 120, the most used angle in physics, which is minus 1 by 2. And you can have cos 150 also, cos anything. It can be any angle. You have to be ready for any kind of questions. Then I talked to you about electric field. I said you electric field is not only the area around the charge where its effect can be felt, rather it is also force experienced per unit test charge. Whenever a test charge is placed in the vicinity of an existing charge. So for an existing charge, how much force it exerts on the test charge, that determines the electric field. So electric field by the formula is F by Q naught, where Q naught is the test charge. So obviously its SI unit will become Newton per Coulomb. Then I told to you and derived for you what is the electric field due to a point charge, and the formula was E is equal to KQ by R square, where K is 9 times 10 to the power 9, Q is the charge of which you are finding the electric field, R is how much distance away you are finding the electric field. Then we solved questions based upon it. Once again, you have questions linked with vectors. Then you have multiple charges. They may ask you to find the electric field at the centroid or in the corner or somewhere, where again you will keep a test charge wherever they ask you to find the electric field. The test charge is just an imaginary charge which helps you to determine the direction of the electric field. Suppose you have plus 5 Coulomb charge. If I keep a test charge, it will be repelling it. If it is a minus 2 Coulomb charge, it will be attracting it. So just to determine the direction of electric field, we keep the test charge. And then accordingly we find net electric field. Moreover, I even told you some questions where they may give you the two charges and they may ask you where between them the electric field is zero. Very common question in the board examination. If they are like charges, both are positive or both are negative, then the point at which the electric field is zero is going to lie between them in the line. If they are unlike charges, plus 5 Coulomb, minus 5 Coulomb, then it will be lying outside the line. Be careful about this kind of question. Then comes electric dipole concept. Very important. I taught in the previous class to you. Dipole is an arrangement of two charges which are equal, opposite, have a small separation between them. That small separation we take it as 2D. Why 2D? Because it helps in the derivation of it. We can take D also and take D by 2, D by 2. The derivation will become more complicated. That is the only reason we are taking 2D. And so its SI unit, I am talking about a dipole moment now. Dipole moment is given by charge times distance between them. Now distance is 2D, Q is charge. Dipole moment is directed from negative to positive charge. It has a direction, it's vector quantity from negative to positive. Also I told you that when you find the electric field due to electric dipole at an axial point, the value of electric field is K into 2P by R square minus D square the whole square. And if you find the electric field due to electric dipole at an equatorial point, you get electric field equal to K into P by R square plus D square power 3 by 2. In the case, if R is much more than D, then we get electric field is equal to K into 2P by R cube for axial point and K into P by R cube for equatorial point. They may ask you in the examination, prove that E axial is 2 times E equatorial if R is much more than D. Derivation you know very well. Derivation is very important. In both the cases where we are finding the electric field, we keep a test charge, found directions, solve it and get the answer. Then in the last class, I talked to you about torque on an electric dipole placed in uniform electric field. Very important concept. Where I told you that what happens if a dipole, electric dipole, is placed in a uniform electric field and what happens if it is placed in a non-uniform electric field. If it was placed in a uniform electric field, it experiences a torque which turns it. Turns it with how much torque? Pe sin theta. Dipole moment, E is electric field, theta is the angle between dipole moment and electric field, which very clearly tells that if a dipole is placed perpendicular to the electric field, it experiences the maximum torque, and if it is placed parallel or anti-parallel to electric field, it experiences the least torque, which is 0. Also, I told you that this dipole, if it is placed in non-uniform electric field, which means electric field value is changing from point to point, then a dipole will not only experience the rotational force, it will also experience translatory force, which will make it to not only rotate, it will move also. Rotate and move. Rotate and move. Are you getting my point? So it's very important. Up to here, we have seen in the previous class. Today, we are going to learn two very important topics, which are electric flux and Gauss law. Let us see how much you are able to do today in the class. But important topic, electric flux. Question is definitely going to come in the board examination. Today's class becomes very important. Give the heading as electric flux. Everybody, please give the heading as electric flux. Electric flux is represented by the symbol phi. Electric flux is represented by a symbol phi. Yeah. Now drop your pens, listen to me. I will give notes for this. Please pay attention. Okay. First of all, this flux word is not just a normal physics word. It's an English word. Anybody has heard this word flux before? What is the meaning of the word flux? Any idea? You can be right or wrong, never matters. But any idea about the flux?
Intensity.
What do you say, Harshita? Come again, please. Density.
No, intensity.
Intensity. Okay, fine. Intensity, she says. Anybody else who wants to say something about flux?
It is a measurement of electrical field in a given presence of given surface.
Electric field on a given surface, you are saying.
Yes, sir.
Okay, you are going technical. I want layman's word. Not in physics. Generally, what flux means?
Sir, flux means flowing.
Yeah, please, Indumati, go ahead. Be louder. I am unable to hear you. Indumati, if you are saying something, yeah.
Flowing, sir.
Flowing.
Out.
Good. Exact meaning of the word flux means coming out or going out or passing through a particular surface. So imagine you have a window in your home and there is wind passing through your window. That will be air flux or wind flux, you can say. Suppose I am having a channel and water is passing through that. It is water flux. Are you getting what I am trying to say? So flux means anything flowing or passing through a given surface. Same way, if it is electric flux, it is defined as, write the notes, get the definition. Electric flux is defined as the number of electric field lines. Electric flux is defined as the number of electric field lines. The number of electric field lines passing, the number of electric field lines passing normally through an area. Passing normally through an area. Mathematically, it is given by right here, phi is equal to E A cos theta, or phi is equal to E vector dot A vector. You can also write one more statement. Electric flux is the dot product of 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 electric field and area vector. Electric field and area vector. Electric field and area vector.
Electric flux is dot
Dot product of electric field and area vector. Electric field and area vector. Now, I hope you remember from your 11th standard what is the meaning of dot product. Dot product is not new for you. Work is dot product of force and displacement. So, A vector dot B vector is equal to AB cos theta. That is a dot product, isn't it? A vector cross B vector is equal to AB sin theta n cap. That is cross product. I think you learned this in vectors in 11th standard. The same thing here. So, dot product of electric field vector and area vector is called as electric flux. Now, pay attention. Do you think area is a vector quantity? Not actually. Length, area, volume, they are not in direction. They are scalar quantities. And suddenly, why I am writing area vector? Area vector is not as area. Tell me, yeah, Raghav. Area vector is different from area. If this is the book, then this is the area, right? Is it vector? No, it is scalar because it has no direction. What is the meaning of area vector then? Over this area, if I draw a perpendicular, this is called as area vector. Are you getting what I am trying to say? This is the area and you draw a perpendicular on it. What is this? Area vector. So, what is area vector first of all? Area vector is perpendicular drawn on a particular area, and it will obviously have a direction, isn't it? Area I cannot define what is the direction, but area vector I can define, no? Y plane, y axis, or in this case maybe x axis or minus x axis, like that. Area vector can have a direction. And what is the meaning of the word area vector? It is perpendicular drawn on a particular area. In the upcoming 3-4 chapters, many times you will hear the word area vector. And whenever I say the word area vector, what you should realize, I am talking about perpendicular drawn on a particular area. If you have area, perpendicular is area vector. Is it clear to you? I hope it is clear to you. Now, coming back. So, here I have defined electric flux as how much? E into A into cos theta or E dot theta. What is the meaning of theta here? Theta is the angle made between what and what? Made between electric field and area vector. Please note it down. Theta is the angle made between electric field and the area vector. Now, everybody pay attention. Suppose I am having a square. Everybody please pay attention. Something important I am asking you, please. I am having a square, okay? This square is having dimension of 1 meter cross 1 meter. So, I have 1 meter cross 1 meter square, 1 meter square, square lamina, square plane. And on this, I have electric field passing perpendicular to it. This electric field has a value of 20 Newton per coulomb. Is my data clear? I have told there is an area. How much area? 1 meter cross 1 meter cross 1 meter area is there. And through this area, I have what passing? Electric field passing. How much electric field is passing? 20 Newton per coulomb. Now think and tell me, what would be the electric flux through this surface? Any idea? This is the formula here. E I have given, area I have given.
It will be electric field times the area.
How much will be that?
It will be 20 Newton per coulomb times 1 meter square.
Okay. SI unit will be how much? You check here. Electric field is Newton per coulomb and area is meter square. So its unit will become equal to Newton coulomb power minus 1 into meter square. Right. So you say the answer is 20 Newton coulomb inverse meter square. Am I right, Surya?
Yes.
Okay. Anybody else who has some other answer? Loudly? 0. Okay. I have got some answer as 0. What do you think, Harshita Shri? Harita Shri. Okay. 0. Jagdishwaran, what is your opinion? No opinion. Man, electric field is there. area is there, theta is there, formula is there. You cannot multiply and tell me the answer. Why are you giving up? I don't like giving up attitude. What is your answer? Obviously 0 because theta is 90 degree, right, Mr. Vijay? Some of you may think like that, but you forgot the definition of area vector. Area is not this. Area vector is on this area perpendicular drawn. Am I right, Harita? Now tell me what is the angle between area vector and electric field? 0. They are parallel to each other. So EA cos 0. 20 into 1 into cos 0. Cos 0 is also 1. What is the answer then? As told by Mr. Surya, answer is 20 Newton Coulomb inverse meter square. Are you getting why the answer is not 0? If I would have asked you, this is the area, electric field is going like this. Then what is the flux? What is the answer? 0. Because area vector is like this, electric field is going downwards, angle between them is 90 degree, then the answer will be 0. Are you getting my point? Are you getting my point? One more way of thinking is there. Please pay attention. Something conceptually we are learning. I said the first definition of electric flux as number of electric field lines passing normally through an area, right? If this is the area and electric field lines are passing like this, right? Then obviously electric flux will have a finite value because they are passing through it, lines are passing through it. But if I make electric field going like this, is any electric field passing through the area? No, right? Then flux will be automatically 0, theoretically also. Forget about mathematics. Flux will be 0 because nothing is passing through it. And definition says that electric flux is number of electric field lines passing normally means perpendicular, normally through an area. Are you getting what I'm trying to say? So theoretically also answer is 0, and mathematically also if I see answer will be 0 for this. And for this question, electric flux can never be 0 because something is passing through the area. I hope you are getting this. Very basic question I gave. So whenever you have a given area, you are supposed to find the area vector, check its direction, put in the formula, get the answer. Can I proceed? Can I proceed? Now I'll give you an interesting question. Shall I give? Shall I give a question to you guys? Please. You want to write something from here or shall I go to the next page? I can go, right? Okay, make it fast, please, if you're writing something. Okay, now everybody please pay attention. The question is like this. Everybody see the question and then solve it. Question is, there is an electric field here, uniform electric field, okay? And let us assume that electric field is anything, 100 Newton per Coulomb. You saw the electric field, how it is? Electric field is going, uniform electric field, and what is its value? 100 Newton per Coulomb. In this uniform electric field, I am placing a cube. What I am placing? A cube. I hope you are able to see the cube. And cube has a dimension of, for your easiness, 1 meter by 1 meter by 1 meter. Easy to solve. Okay? So I have a cube of dimension 1 cross 1 cross 1 placed in a uniform electric field of 100 Newton per Coulomb. Question is, what is the electric flux? Before you start solving it, wherever you wrote the definition of electric flux, also mention one thing. Electric flux is a scalar quantity. Mention that please. Electric field was vector. Electric force was vector. But electric flux is what quantity? Obviously, it will be scalar because it is dot product. Common sense says that. Dot product is also called as scalar product, isn't it? It will be scalar only, anyhow. So, question is in front of you. Take not more than 3 minutes and solve this. 2 to 3 minutes, get me the answer. Make it fast, please. Take 2 or 3 minutes and tell me the answer. Everybody, please. I want the answer from Karthikeyan. Okay, Karthikeyan?
Yes.
Yeah. Think and solve. Think and solve. I'll help you. Everybody, please go ahead. I hope the question is clear to everybody. Very simple question. We have a uniform electric field, and this uniform electric field, I am keeping a cube, 1 meter cross 1 meter cross 1 meter dimension, and I am asking you to find what is the net flux through this cube. Any answer you have got? Think wisely. Take 1 more minute. But 100 Newton per Coulomb meter square. Okay, one answer is there. Jagadishwaran says that answer is 100 Newton per Coulomb meter square. Anybody else? Any answer?
200.
200 is the answer given by Akhilesh.
So 16.6.
16.6 is the answer given by Shoaib, right?
Yes, sir.
Okay. Anybody else? 200 is the answer by Surya Kumar also.
Sir, 200 Newton per Coulomb per meter.
Okay. I have some answers in my hand now. Now everybody stop trying and listen to how I solve this question. First question of this kind, let me do it for you. Second question you will do by yourself. Okay. Everybody please pay attention. Interesting question. This kind of question comes in the exam also for 1 mark. Not more than that. I'll tell you why 1 mark. Okay. Everybody please pay attention. If there is a cube, how many faces a cube will have? Nobody has doubt in that? We have 6 faces, isn't it? Okay. All 6 faces will have their own area vectors. If there was 1 face, I drew area vector easily. I have 6 faces now. So, don't you think that area vector here, I will write it as A1 cap. This side I am writing it as A2 cap. Below I am writing as A3 cap. Above I am writing as A4 cap. Towards me, A5 cap. Away from me, A6 cap. Anybody has doubt in this? If there is a cube is supposed to have 6 area. Imagine in this room itself, electric field is going from my left towards my right. And then there is a cube kept here. This cube will have 1 area down, 1 area up, 1 area towards my right, towards my left, towards me, towards you. Am I right? 6 area vectors are there. Now tell me, out of all the 6 area vectors, which area vectors are perpendicular to electric field? There are few area vectors which are perpendicular to electric field. Am I right? Which are those? A4, A3, even A5, A6. No, yaar. Imagine this is the direction of electric field. Okay. This is A4, obviously perpendicular. This is A3, obviously perpendicular. This is A6, obviously perpendicular. This is A5, obviously perpendicular, right? Towards me perpendicular, towards you perpendicular, downwards perpendicular, and upwards perpendicular. So 4 faces are perpendicular to electric field. Do you agree? Which makes zero flux immediately because EA cos 90 is going to be 0. Anyhow, I am writing it for you. So total flux will become equal to phi 1 plus phi 2 plus phi 3 plus phi 4 plus phi 5 plus phi 6, out of which 3, 4, 5, 6 will be 0. Why is it going to be 0? Because it is EA cos 90, EA cos 90, EA cos 90, EA cos 90. So I am going to get net flux only because of two areas, which are A1 and A2. Now tell me, what will be phi 1? Don't you think it will be E into A into cos? How much cos? Cos 0, isn't it? Why cos 0? Because area vector and electric field are parallel. Do you agree with me? Second will become equal to E into A into what is cos here? 0. How you are saying? Electric field going like this, area going like this. What is the angle between them? 180. Very good. EA cos 180. Am I right? Now what is cos 180? Minus 1. So I am going to get EA minus EA. How much is that? That's why it is a 1 mark question. Indumati, please ask me what you're asking.
Sir, instead of like taking the angle between A2 and A1, can I do separately? Like A2 is in the opposite direction, so it will be negative.
Yes,
So
you
I
can.
do like that.
You can do. That is layman's way of doing, but it is also right. They are opposite, so they are going to cancel each other. But the correct way of doing is EA cos 0, EA cos 180. One more way of doing is there. I'll tell you that way also I'll tell you. Now please pay attention. Another way of thinking is net flux, Janani, I'll give time for copying. No problem. Please pay attention. Net flux through any three-dimensional object. Remember my words. Net flux through any three-dimensional object is always equal to number of electric field lines entering minus number of electric field lines exiting. If 5 line enters, 3 lines rejects, 2 will be the value of electric flux. Are you getting? Number of electric field lines entering, how many are leaving, subtract both, that will give the net flux to you. In this case, number of lines entering and number of lines exiting are same, right? Net flux is going to be 0. One more thing I'll tell you. Any symmetric object placed in uniform electric field will always have 0 flux. Mind my words, uniform electric field, only for that. What will happen if it is non-uniform? We will do it today. Next question. Okay, but is this clear to everybody? If it is clear, don't take more time, copy it fast.
Sir, can you explain that number of lines entering and exiting?
See, if they say that through a surface, 100 lines are entering and 50 lines are exiting, what is the net flux? Answer is 50. Okay. Here we can see how much are entering, same amount of lines are leaving. So 0. Tell me,
What is the reason it's only keeping 50 exiting?
come again.
What is the reason behind coming?
It may go in this direction, random directions. Why it has to be always going straight? Okay. Yeah, tell me, Raghu. See, this was the area vector, right? And he is in SSM Nagar, man. He's not here. You want something? Later. If you want, come tomorrow. So this is the area vector, and this is the electric field direction. Raghav, for you only I'm telling. So area vector and electric field, they both have same direction, right? What is the angle between them then? 0. This case, electric field is going in this direction only, but area vector is in this direction, opposite direction, right? What is the angle between them? This and this. What is the angle between them, guys? What is the angle between this line? Huh? 180, obviously. Are you getting my point? This is 0, 90, 180, isn't it? This is 0, right? Parallel. Then perpendicular, 90. Then anti-parallel, 180. So this face, I'm talking about the second face, this face. And this face. This area vector is parallel. This area vector is anti-parallel. So obviously no flux. That is cos 180 minus 1. Are you getting, Raghav? Sure? Shall I give another question?
Sir, if the length is different, what will happen?
Length is?
The length is different.
Length means it is a cuboid you are saying.
Yes.
It will still be 0, no? Because cuboid also, opposite sides are having same dimensions, right? But if it is, as you are saying, some shape is there which is irregular shape, it may not be 0. Okay? Now coming back. Take one more question of the same kind before I go to the next concept. The question is very similar. There is an electric field of value 10 Newton per Coulomb, uniform electric field. In this uniform electric field, I am placing a cylinder which has dimension of radius of the cylinder is 1 meter and length of cylinder is 5 meters. Is the question clear? There is a cylinder having a radius of 1 meter, length of 5 meter, placed inside a uniform electric field. What would be the net flux through this cylinder? What is the answer? What is the answer? Can you think of it?
Sir, 0.
Why do you say so, Surya?
Sir, because the rounded part of the cylinder, it won't be counted because it's perpendicular to the electric field,
Very good.
and one side is cos 180 and the other side is cos 0, so it will be cancelled out.
Great. What he said as a rounded part is curved surface area, isn't it? This curved surface area is always going to be perpendicular only, isn't it? And if it is going to be perpendicular, cos 90 is 0. So flux will be only because of this area vector, A1 vector, this area vector, A2 vector. Once again, EA cos 0 plus EA cos 180, which will be EA minus EA. Answer is going to be one more thing. Same to the previous question, symmetric body kept in uniform electric field. Number of flux entering is equal to number of flux exiting. Answer is supposed to be 0 only, isn't it? Is it clear to you? Sure? Anybody has doubt, please ask me. These kind of questions are asked in 1 mark in CBSE board examination. Even if it is asked for 1 mark.
Can you explain on seconds?
Okay, now please pay attention. So what I am doing here is, this is cylinder. So if you see cylinder, it has 3 kinds of area. One is this area, circle. Area vector is in this direction. Another area is in this direction. A1 cap and A2 cap. Third area is curved surface area. It can have any direction. Like if you see this as a cylinder, then anyway if I take this area vector is perpendicular to the electric field. But if I say this face, it is parallel to electric field. This is the electric field. A1 is parallel to electric field and A2 is anti-parallel. So A1 is making an angle of 0 degree, A2 is making an angle of 180 degree. So EA cos 0 plus EA cos 180, cos 0 is 1. So EA plus cos 180 is minus 1, minus EA. EA minus EA is 0. Got it?
Yes, sir. Thank you, sir.
Yeah. Is it clear to everybody now? Can I take it like that and move to the next concept? A new concept, shall I? Please mind that whatever I taught you now is for uniform electric field. There may be a scenario where you have a non-uniform electric field, isn't it? Are you getting my point? Why the electric field has to be always uniform only? It can be non-uniform also. And if it is a non-uniform electric field, it may not have 0 value. One question, very famous question is there. I'm drawing it for you. You can draw along with me. There is a cube kept like this. For easiness, cube is having a dimension of 1 meter by 1 meter by 1 meter. Okay? And this cube is placed 1 meter away from the origin. So I have a cube having a dimension of 1 meter across 1 meter across 1 meter placed 1 meter away from the origin. And they have given there is an electric field acting following an equation Ex is equal to 100 root x I cap. Obviously, Newton per coulomb. Okay. So what is the electric field? 100 root x I cap. Newton per coulomb. They will ask you to find what is the net electric flux through this cube. If you think the answer will be 0, definitely not. Because electric field here is varying electric field. Varying with respect to what? X. So if the distance is changing, electric field is changing. If I am going 1 meter away, electric field is how much? 100 root 1. I am going 2 meter away, 100 root 2. 3 meter away, 100 root 3. 4 meter away, 100 root 4. Are you getting my point? Electric flux is changing its value as the distance changes. So it is a non-uniform electric field. Now think for a while, take 2 minutes, solve this question, tell me the flux, fast, make it fast, don't delay. Everybody give a try. Everybody please give a try, it's a good question. Any answer? Please break down the question into different flux and find. So obviously we have 6 area vectors here, and once again this area vector downward, towards you, away from you are perpendicular to electric field, isn't it? Which is in y direction, minus y direction, z direction, minus z direction. They are obviously perpendicular to x. No flux. Flux will only be because of this face where the area vector is like this. I am writing it as A1 vector, and this face where I am having A2 vector. Am I right? So common sense says that the flux, net flux will become equal to phi 1 plus phi 2. Now what is phi 1? First phase, what is the flux? Ea cos theta. What is E? 100 root x. At this distance, what is the value of x? For this phase, what is the value of x, guys? 2. Very good. Because 1 plus 1, 2. 2 meters. So it will be 2 here. This is the value of E. What is the value of A for this phase? 1 meter cross 1 meter, 1 square. So into 1. Cos how much? Electric field and area vector. How much? Cos 0. Very good. Plus, for phi 2, what is the area? 100 root x. So for this phase, what is the distance from here to here? 1. So 100 root 1. Into area is how much? 1 square. Into what is cos here? 180. Very good. Because area electric field is acting in I cap direction and A2 is in minus I cap direction, isn't it? Now solve this over. Answer is 100 root 2 cos 180 is minus 1, so minus 100. If you solve this, it will be 100 common root 2 minus 1. What is root 2? 1.414 minus 1, 0.414 times 100, 41.4, isn't it? So 41.4 Newton Coulomb inverse meter square is the answer for the net flux through this cube. If anybody has doubt, please ask me. This kind of questions are very important for the examination.
Can you explain the A2?
I'll explain, ma'am. See here, this area is having an area vector in positive x direction, right, Akhilesh?
Yes, sir.
And the second area is having area vector in negative x direction.
Yes, sir.
So here the angle made between the area cap and electric field is 0 degree.
Yes, sir.
And here the angle made between area vector and electric field is 180 degree.
Yes, sir.
So I wrote here cos 0 and here I wrote cos 180. Moreover, one second, let me complete. Moreover, electric field here and electric field here are not same. Why I say so? Because this phase is present 2 meter away from the origin and this phase A2 is present 1 meter away from origin, right, Akhilesh?
Yes, sir.
So electric field depends upon x. So for the first phase, x is 2. For second phase, x is 1, right?
Yes, sir.
And the formula for flux is EA cos theta, right, Mr. Akhilesh?
Yes, sir.
So for the first phase, E is 100 root 2. What is the area for this square? 1 cross 1, isn't it?
Yes, sir.
And area for this square, once again 1 cross 1.
Yes, sir.
So that's why I wrote 100 root 2 into 1 cos 0 for the A1, 100 root 1 into 1 cos 180 for second phase. Now tell me what doubt you have.
Understood, sir.
Okay. Yes. If they would have told 100 root x j cap, then the area will be taken only for these two directions, isn't it? Then the other four phase will be 0. It will be E into this A1, or I can take A3 and A4. If they would have told Z K cap, then it will be only because of towards me or away from me. Are you getting what is the simple logic is there? Yes.
Solving why you didn't take I cap.
By solving?
Why you didn't take I cap, sir?
Where I not took I cap? When I solve, where I solve for y man here? Ex only. Here we have only in x direction, no man. Electric field is acting only in x direction. In this question, I have assumed Ey and Ez to be 0, isn't it? If they would have given Ey, Ez, then it will become a little more complicated. You have to find for each flux, for each direction. Is it clear to you? Please. How it came? Okay. This step is clear to you? 100 I took common in both. If I take 100 common, in this root 2 is there? And this how much is there? Only 1 is remaining. So root 2 minus 1 came. Root 2 is 1.414. 1.414 minus 1 is 0.414. 0.414 into 100 is 41.4. Got it, Gopi? Okay. Fine. Next topic is Gauss law. But time is not permitting me to start Gauss law because it needs some time to make you understand the real concept behind Gauss law. Okay. So I will wind off here at my today's class. And today we have learned, see, I'm going very slow, guys, dead slow I'm going. But my concept, you always know. Everybody who sits in the class should understand the class. That's my first priority. Let me go slow also, no problem. But I always try to make you understand things. And if you're not understanding, please approach me. Learn from me. And don't let topics go without understanding. Otherwise, after a month, you will have accumulation of lot of things which you don't know. Don't let it happen. Each topic that I am teaching here in the class, please attend the practice class very seriously. In the practice class, you will be given some questions from the book and those questions have to be solved on that day. Solve it honestly by yourself, without talking, without referring online. You can use the book and notes. Solve it. Doubts are there, ask it. Anyhow, ma'am will help you in all the question. If you take all the practice class seriously, regular class seriously, nobody can stop you from scoring 90. However, the question paper is tough, easy, nothing. Don't worry about the world, what they are saying. I have told you always, tough is a relative term. For something, it may be, someone it may be tough. For someone, it may be very easy. Prepare yourself that much hard that things become simple for you. Okay. So if you solve the past year questions, you will get an idea of what are the different ways the questions can be asked in the examination. NCERT example, NCERT exercise must be solved. So let me give you homework today. Everybody who's there in the class, please make sure that already you have solved till 1.6. So I have told you to solve 1.1 to 1.6. Now I am extending it 1.7 to 1.11. Example I am saying 1.7 to 1.11, and in exercise from 1.7 to 1.15. I am writing it here also. Example question from 1.7 to 1.11. This is example. From exercise, it is 1.7 to 1.15. These questions must be solved before my next Monday's class. Tomorrow, I'll check with Satish sir. If he permits me, tomorrow I may come for the class. Or math class will be there. What class will be there? It will be put in the group to you. It can be either my class or math class. Saturday, you have 2 hours of chemistry class. Remember that, 7 to 9. But tomorrow, it will be either my class or Satish sir class. If it is my class, I will finish Gauss law. That is the last topic of this chapter. If it is math class, I will finish by Monday. Okay? But before my Monday's class, take very seriously, try all these questions. And whichever question you are not able to solve, approach me or approach ma'am, make it clear. Is it clear to you? So, guys, let us take a break. Bye-bye, take care, good night. I hope you have understood the class today. Take care, bye-bye.
Thank you, sir.
Sir,
Bye.
when you discuss derivations,
Thank you, sir.
Bye-bye.
when you
Ma'am will discuss, or what will you discuss? Tell me the question. One day when you had practice, that's why I'm sitting here in the class.